Hey guys, what's going on? It's Dave from Evil Eye Games. Today's video we're going to continue on with getting our player character to do stuff for us. We've already established a character which gives us sort of a presence in the game, but now we need the character to actually do something for us. And in particular today, I want to address getting the character to move and to be able to look around within the game world. Now, in order to address the character moving around, we want to understand how this would work in the game. So essentially, we're going to have a player, and that player is going to press some buttons on a keyboard. And when he presses buttons on a keyboard, or even in the case of a controller, we want the character to do something within the game world. So the game engine is going to have to interpret some inputs, and it's going to have to redirect those to our player character, because in our player character we have a movement component that we want to access, and this movement component is going to be responsible for actually moving our game character around. So we have to set up some kind of input system that the engine is going to interpret. We have to get that input interpretation to our player character, and then we have to go ahead and we have to call upon the movement component to go ahead and get the character to move around. So to start out with, we're going to set up those inputs, and Unreal Engine already has a input system or a key binding system that exists in place as is, and we're going to take advantage of that. So to get to our key bindings, we're going to go up to the Edit menu, and we're going to find Project Settings. Inside of our project settings, underneath Engine, about halfway down, we have Input. So I'm going to click on that. And at the top of our Engine Input, we have a segment titled Bindings. And the first thing is to understand what bindings are. Basically, a binding is going to attach some kind of event to some kind of action. So essentially what's going to happen is when the player hits a key, that action of hitting that key is going to be bound to some kind of event that occurs that is pre-scripted. Now, the two types of bindings we have available are action mappings and access mappings. Action mappings are very simple in that they're more event-driven. They will tell us when a key has been pressed or when a key has been released. So this is very useful for instant actions that you want the player to take, or something that you want to occur while the button is being pressed down. Access mappings, on the other hand, monitor a input continuously, and they will report a level of interaction with that input. And the best way to explain this is thinking about an analog joystick. Now, with an analog joystick, you can move the joystick around in various percentages of positions. So if you move the joystick fully forward, it would present the full value of that movement. Whereas if you only move the joystick forward about halfway, you want to be able to tell that that joystick has only been moved halfway. And this is what we generally use for movement inputs. We could use action mappings for keyboard buttons for movement, but to kind of lump everything together and make it much easier for us to determine at runtime, we want to go ahead and put all of our movements and our looking actions into the access mappings. So we're going to create some access mappings. So I'm going to use the plus button next to access mappings. And it doesn't drop down at first, but it presents us with this arrow to the left of access mappings. So I'm going to click that to drop down the menu below it. And we're going to need a total of 4 different access mappings. We're going to need one for moving forward and backwards. We're going to need one for moving left and right. We're going to need one for looking up and down. And we're going to need one for looking left and right. So I'm going to hit the plus button 3 more times, so we have a total of 4 access mappings that we're going to use. And the first access mapping, I'm going to name this one Move Forward. And you'll notice I'm using what is known as camel case. If you haven't heard that before, it's basically giving a name to something without using spaces in between, and then using capital letters to indicate the change in different words. So in the case of move forward, I've typed it as one word, and then I've just given the first letters of each word a capital letter. This is a very common practice inside of programming, and it's something you're going to see a lot. generally because most things can't have spaces within their actual names. So it's a good practice to start getting into to make sure that you're using something like camel case to name things. Our second input here, I'm just going to go ahead and name these real fast, is going to be move right. Now there's a particular reason I'm using right here, and I'll show it to you when I get into the character, but it's going to have to do with how we calculate directions from the character. The third input here, I'm going to go ahead and I'm going to call this look pitch. And finally, the last input, I'm going to go ahead and name look yaw. So for our move forward, this one's going to be pretty straightforward. We just need the buttons that are going to move our character forward and backwards. So I'm going to go ahead and this first input here, I'm going to click on the drop down and I'm going to search for the W key. And under keyboard here, there is the W key. And we want to use that. That's pretty much standard fare for any PC game nowadays when you're using a keyboard. And we also have to address moving backwards as well. So we're going to add a new key. And in that new key, I'm going to use the S key. Once again, pretty standard fare. But we want it to move in the opposite direction as the W key here. So I'm going to change the S scale value to -1. And that's going to basically, when we hit the S button, provide a value opposite of the W button. Finally, I'm going to add in for a controller because I've been asked about this. And really, with a controller, it's the exact same thing, except the stick will automatically handle both ranges of directions. So you don't have to determine what moving a joystick forward and backwards does. You just have to basically define what the axis in total does. So I'm going to go ahead and add another key. And under gamepad, I'm going to go ahead and find the left thumbstick Y axis. That's the up and down or forward and back axis. The engine will go ahead and interpret the inputs from the joystick. So if I push it all the way forward, it's going to provide us a value of 1. And if we move it all the way back towards us, it's going to provide a value of -1. So for move right, we're going to do pretty much the same thing. So we're going to need 3 inputs in total. And the first input, I'm going to go ahead and I'm going to start with a D key here. So under keyboard, we're going to find the D key. I'm going to select on that. And we want the positive scale to be 1 because we're using to the right as a positive value in our movement. Next, we're going to have to do the opposite direction. So that's going to be the A key on the keyboard here. And once again, because we want to move in the opposite direction of the D key, we want to set this value to a -1. Finally, we're going to have to deal with the gamepad. So for the gamepad, we're just going to find that gamepad left thumbstick. And for the move right, we're going to use the X-axis. So Y-axis is forward and back, and X-axis is the left and right. And then for our looking inputs, we're going to need to have 2 apiece for these, one for the mouse and one for the thumbstick on the gamepad. So for the mouse, we're just going to search under mouse here, and we're going to find that there's a mouse X and Y, and the pitch is obviously going to be the Y. Now, one thing to note about the mouse pitch input is, strangely enough, this seems inverted from all of the other inputs. So if you move the mouse away from you, that is going to provide a negative value, and if you move the mouse towards you, that's going to provide a positive value. So in order to keep up with standard mouse inputs, I'm going to set this value to a -1. And that's going to make it so that when I push the mouse forward, we're going to look up and it's going to provide a positive value. And if I move the mouse down towards me, it's going to provide a negative value and the character is going to look down. Now, at a later point, you can go ahead and add in an option in a game to go ahead and invert this value. But just for our testing and for what we're doing right now, and the fact that I prefer that sort of setup for the mouse, I'm just going to use the -1 value. And for the next input, we're going to use the gamepad. So we're going to select under gamepad here, and we're going to look for the right thumbstick, and we want the right thumbstick y-axis. And if I remember correctly, the y-axis on the thumb pad is going to provide a positive moving forward if you push the stick forward from you, and a negative if you pull it back towards you. And finally, we have the look yaw. So here in the look yaw, we're going to need 2 inputs as well. So for the first one, we're going to find our mouse, and we're going to have the mouse X. So that'll handle our left and the right. And then we're going to need to add in the gamepad, the right thumbstick X-axis. And that is going to complete the setup for our bindings. So at this point, we don't need to hit save because the project settings are automatically saved for us when we make changes. So we can actually just go ahead and close out of the project settings. So we have the first part of our task complete in getting input set up. We have it set up so that the Unreal Engine is going to go ahead and interpret the buttons that we press. So if we press one of the buttons that we've set up already, it's going to trigger something else to happen. Now we actually have to set it up so that the buttons, when we press them, actually trigger something. Now to keep things simple, I'm going to go ahead and I'm going to put all of our input controls into the player character itself. So we're going to go ahead and move into our player character blueprint. So I'm going to double click and open that up. And we're going to want to be in the event graph tab at the top here. So there's 3 tabs. There's a viewport tab that shows the representation of our character in the game. There is the construction script. And the important thing about the construction script to keep in mind is that it runs when our character is loaded into memory, but before the game has actually started. And then finally, we have the event graph. And the event graph is where we're going to put a lot of our logic and how the character will actually function. So I mentioned earlier that when we bind keys or when we create bindings, what they're going to do is they're going to trigger some kind of programming to go ahead and execute. So automatically, Unreal Engine already generates those events for us. So we just have to call upon those events within our event graph. So if you've never moved around in one of these graphs before, if you want to maneuver in the screen, you just have to right click and drag around, and you can move around the graph as so. But we're going to need to get those events for our inputs. So in an empty space in the graph here, I'm going to right click and we're going to search for our first input, which is move right. And you're going to see 2 results for this. One of these is going to be an axis event, move right, and the other one is going to be an axis value, move right. We want to actually call upon the event itself because this is going to provide us with an execution chain to get code to run. The move right function is not going to have a trigger to start movement, which is kind of a bad way of explaining it, but the important thing to note here is we want the actual axis event. So we're going to left click on that, and we're going to have an input axis move right. And it provides us with this white arrow to the right, which is our execution chain, which basically says that when this is triggered, it's going to go ahead and execute code that occurs to the right of this and is connected via a white line. The second output that it has is an axis value, and this is going to give us the value of the key. So basically, if you're using something like a keyboard, the keyboard is an on-off switch, so it's going to provide us either with a 0 value or the full value. So in the case that we press the W, when it's released, it's going to provide us a value of 0, and when we press it down, it's going to provide us a value of 1. But if we use something like a controller, when you start pushing that stick forward, it's going to continuously update this value. So as you slowly push the stick forward, for example, it's going to read the amount that the stick has been pushed forward and give a value between 0 and 1. And these values are how we're going to go ahead and control our character. So, like I mentioned before, we have to actually get the character movement to go ahead and move our character. And we're going to call upon a function that already exists. So we're going to right click into the graph in some empty space, and I'm going to search for add movement input. And we're going to find under input, there's a function designated by that blue F there that says add movement input. So we're going to go ahead and we're going to grab that. And we want to connect the execution chain from our input access move right to our add movement input. And we're also going to need to handle our move forward input as well. So I'm going to right click in the graph in an empty space here. And I'm going to find move forward. And once again, we want to make sure we're using the axis event and not the function under axis values. So we're going to call upon that as well. And I'm just going to kind of space these out a little bit here, not too far. And we're going to need another copy of this add movement input here. And you can go ahead and right click in the graph and search for add movement input again. But if you want to copy something really quickly inside of a graph like this, you can go ahead and select what you want to copy. So I'm going to left click on add movement input and then move your mouse into an empty space on the graph and hit Control W. And this is going to copy whatever has been highlighted. And it looks like I double hit it. So I'm going to go ahead and get rid of one of those. And we're going to connect the execution chain up to the add movement input that we just added in there. And I'm going to space this out just a little bit. So for these add movement inputs, you're going to see that first of all, there's a target, and we want to target the character that we're in. So in there by default is self, which means that Blueprint basically wants to call upon itself to do this. And that's perfectly fine because we want this blueprint to move around in the world. The next thing we're going to need is a world direction. So we need a direction that we want the character to go ahead and move in. So what we're going to do is I'm going to right click in the graph in an empty space over here, and I'm going to search for get control rotation. And we're going to click on that. And what this basically does is, if you remember back to when I was talking about creating some of our files, we didn't end up creating a custom controller. We're just using the default Unreal Engine 4 controller. And what happens is when the game begins and a pawn or a character is spawned into a world, we are given a controller, which is the interface between the player and the game world. And if there is a character or a pawn that we're supposed to use, the controller goes ahead and does what's known as possessing that pawn or character. And basically it kind of attaches itself to the player pawn or the player character. Now, the controller is independent from the pawn or the character. You can actually end up unpossessing and repossessing other things within the game world. But for our purposes right now, we're not going to be doing that. And what we really need to know is the fact that the controller and the character are two separate things. And the controller is kind of latched onto the player character or the player pawn. So we can actually move this controller independently, or we can have the object we're controlling move with the actual controller. But basically what we want to do here is we want to go ahead and it's going to return a value that's known as a rotator, and that's an XYZ value combined into one variable. And we're going to go ahead and we want to break this. So I'm going to drag out and we're going to search for break, and we're going to find the option for break rotator. And we want to go ahead and break this rotator because the only aspect of the rotation from the controller that we're interested in is the yaw. So we're going to actually end up making a new rotator, but we're going to leave out the values for the roll and the pitch. So in the graph right next to it, I'm going to right click and we're going to search for make rotator. And it's going to look like a mirror image of our break rotator. And all we need to do is connect the yaw into the yaw of the make rotator. So this make rotator is going to create a rotator for us, and it's going to go ahead and zero out the roll and the pitch because we don't care about the roll and the pitch. So we're going to need to make some more room here. So I'm going to grab these add movement inputs and drag them off to the right. And then for our move forward here, I've placed this one at the top. We want to drag out from this rotator, and we're going to use a function that's going to tell us the forward direction that our controller is facing. So I'm going to drag out from the return value, and I'm going to search for get forward vector. And that's going to return this function for us, and it's going to output a value in the form of a vector, which, much like the rotator, it's an x, y, z value in one variable. But vectors are generally designed to indicate a direction or a length of some sort, whereas rotators will describe a rotation in space. And we can go ahead and take this return value and plug it straight into the world direction for our move forward. So we want to make sure get forward vector plugs straight into the world direction for our input for move forward. Lastly, we need a scale value. This is going to be really easy. We're just going to take the axis value and plug it straight into the scale value. So that's going to provide this add movement input with a scale at which to add movement to our character. Then we have to go ahead and deal with our move right here. So this is the reason I made move right the positive direction. It comes down to when we grab this rotator here and we drag out, there is a function that is called get right vector. And this is going to give us a direction based off of the direction the controller is facing, but directly 90 degrees to its right. So that is why I use the value of move right, and moving right being a positive value when we set up our control scheme. So once again, we just have to plug this return value straight into our world direction. And then once again, we want to provide the axis value from move right into the scale value of our add movement input that we're executing from our move right. And we can go ahead and just tighten this up. I like to try and keep my blueprints as clean and easy to read as possible. It makes it easier if you have to come back at some later point and figure out what you've done, or if somebody else comes in and wants to know what you're doing. And another great tip is we're going to use what are called rewrote nodes. And a rewrote node basically allows you to take one of these lines and just kind of maneuver it around so that it's easy to follow the line. For example, here in this move forward, we have the axis value line, and it runs straight through our get forward vector function. Now, it doesn't actually do anything engine-wise, but if you're looking at it at a glance and you have a lot of things going on, you can lose track of where these lines are going to. So we can add a reroute node into this green line here, basically by just mousing over it and double-clicking, and you're going to get this little dot, and you can mouse over and left-click and drag as such. And that will go ahead and it will form the line to move through those points, so you can bypass, for example, in this case, passing through this get forward vector, and you don't have to worry about not being able to trace the line as you're reading it. And then for consistency's sake, I'm just going to add another one down here because I'm kind of a little bit compulsive about doing this for my blueprints. So we should, at this point, be able to move our character in the game. So let's go ahead and test that out. I'm going to, at the top here, I'm going to hit the compile button and the save button. And the compile button is going to go ahead and actually pause the changes that we made to take effect. It's also going to do some error checking, so if something we did was obviously wrong, it's going to throw up an error that says, hey, you can't do that. And then, of course, the save button is obviously to commit our changes to the disk. Now we can go ahead and test this out. So I'm going to go ahead and click on the play button at the top here. And since we're inside of the blueprint, it's going to pop up a window that we can go ahead and use. And in order to control in here, I'm going to left click. And then we can go ahead and use the W, A, S, and D keys. And this should move us around the map. And then I have a Xbox One controller that's actually plugged in as well to test this out. So I'm going to use the left thumbstick, and we'll see that our character actually moves about the map. So our movement is looking good. we're pretty much set on that front, so I'm going to go ahead and hit the escape key to back out of that. And before we continue on, to keep things neat in the graph once again, I'm going to go ahead and I'm going to drag and select all of our move inputs right here. And I'm going to put a comment box around that by pressing the C button. And we can just give this a name as being the movement input. And I'll just hit enter to make changes on that. And we can move this entire section of the graph around by just grabbing the header here and left clicking and dragging. And so that'll keep all of our movement input code in one segmented piece, so that's easy to find. So we have our movement input set up. We next have to deal with our looking around setup. So for this, we also created two inputs. So in a blank space in the graph here, I'm going to right click and I'm going to look for the look pitch. And once again, we want to make sure we take the axis event and not the axis value. And I'm going to go ahead and grab the look yaw as well. So I'll go ahead and grab that. And all we need to do at this point is basically drag out from our axis look pitch first. And we're going to search for a function that is called add controller yaw. Or I'm sorry, we're doing the pitch one. That doesn't make any sense, right? So we're going to search for add controller pitch. So we want to make sure the add controller pitch obviously is plugged into the look pitch. And then from our look yaw, we want to drag out and add controller yaw. Like so. And then once again, we just need to take the axis value and plug it into the value input for the controller pitch input and add the axis value from our look yaw into the add controller yaw input. It's pretty straightforward. And of course, the target, we want to target ourselves. And this function ends up adding either pitch or yaw to the controller of a pawn or a character. So we can target ourselves because it's going to, by itself, grab the controller of what's controlling our blueprint. So we're going to go ahead and compile and save. And so now we have our pitch and our yaw inputs plugged in. We can go ahead and test it. And I actually know that this is not going to work right off the bat how we expect it to. But I want to get us into the practice of testing things out after we implement something. That's very important to do. Anytime you implement something new, you want to test it and you want to make sure it works right. So we're going to test it anyway. I'm going to go ahead and hit play here, and I'll click into our window. And you're going to notice that I can go ahead and move left and right, but I can't look up and down. And if I grab the controller, the same thing occurs. I can look left and look right, but I can't look up and down. So we're going to have to fix that. And the reason this is the case, it comes from a setting in the spring arm that holds our camera. So we're going to go over to the left here in our Components tab, and I'm going to click on our spring arm. And underneath the camera settings to the right here, there is an option for Use Pawn Control Rotation. Now, coming back to, once again, the fact that the controller attaches itself to the character, and it has a separate rotation and actually technically a separate position in the world, we want to go ahead and use the rotation from that controller. So right now, the functions we're using here is adding controller pitch input. So it's adding pitch and it's adding yaw to the controller, not the character. So we want the camera to move around with us, and the camera is attached to the spring arm. So by checking on this Use Pawn Control Rotation here, what we're telling the spring arm is that when the controller moves around, move around with the controller and not the character. So that's going to fix our issues with being able to look up and down. So I'm going to go ahead and hit the compile and the save button at the top here. And let's go ahead and hit play. So if I click into our world right now, I can go ahead and look left and look right as before. And if I move the mouse up, we look up. And if I move the mouse down, we look down. And I'll grab the controller real fast. So if I move the thumbstick to the left and the right, it'll look left and right. And if I move the thumbstick up, it looks up. And the same way, if I move the controller's thumbstick down, it looks down. So we now have the ability to move our character around and look around. So I'm going to hit escape to get out of that. And as before with the movement input, I like my blueprints to be neat and easily readable. So I'm going to go ahead and select our inputs for our look. And I'm going to hit the C key for a comment. And I'm going to go ahead and call this our look inputs. And I misspelled that, so let's correct it. And then we can just slide it around the graph where we want to go. And then, of course, because we made some changes, the compile button is going to show that we haven't compiled yet, although it's a technicality because we just created a comment box. So I'm just going to hit the compile button and save. And at this point, we have the ability to move around and we have the ability to look around. So that's going to finish up today's video. In the next video, we're going to start animating our character and make it look like our character is propelling himself around the map instead of just floating around the map in this ridiculous A pose. So if you guys have any questions or comments, you can go ahead and leave them down below. You can also like me on Facebook. I will go ahead and throw a link down in the description. And as always, guys, thanks for watching.